The first time a human looked up and wondered about the night sky, our entire world felt like the center of everything. The ground beneath our feet appeared endless. The sky above seemed like a dome perfectly crafted for us. Yet the moment we discovered that the Earth is only a small planet orbiting an ordinary star, the scale of our home began to shrink. And even now, with telescopes that see deeper into space than any generation before us, the shrinking continues. What feels enormous to us is tiny when measured against the true architecture of the cosmos. The Milky Way, our home galaxy, is a majestic spiral of starlight and invisible matter. When viewed from far away, it would appear like a grand pinwheel floating inside a sea of darkness. Its shimmering arms coil gracefully around a dense central region where stars are packed tightly together. If we could travel from one edge of this disk to the other at the speed of light, it would take a little more than 100,000 years to cross. That distance is impossible for any human mind to truly imagine. Light itself, the fastest traveler in the universe, requires a span longer than the entire history of recorded civilization just to make that journey. And yet, cosmically speaking, this enormous structure is only the beginning. Inside this spiral are hundreds of billions of stars. The exact number is uncertain because many are too faint to count directly, but astronomers estimate somewhere between 200 and 400 billion. Many of those stars are giants many times the size of the Sun. Others are tiny and quiet, glowing just enough to be noticed if you are close. Scattered among them are planets of every kind. Some are worlds of scorching rock. Some are enormous spheres of gas. Some may hold oceans or ice. Somewhere in this population of stars and planets, life emerged on one small world orbiting a gentle yellow star. Our solar system is tucked away inside a minor branch of the Milky Way. The grand spiral structure has several major arms thick with stars and nebulae. We do not live inside one of those major arms. Instead, we inhabit a small sidearm called the Orion Arm. It stretches like a thin spur between two larger arms. If the Milky Way were a great city of 1,000,000 streets, our sun would be a single quiet house on a side road. Nothing about our location suggests we are special. In fact, our position may have helped life survive. We are far enough from the crowded and dangerous core where stars collide and giant black holes dominate gravity. Imagine looking at our galaxy from above. Our sun would appear barely noticeable, a speck halfway out from the center. It orbits the galaxy once every 230 million years. That journey takes so long that dinosaurs were roaming the Earth the last time we were in this same region of the galaxy. Humans have existed for only a tiny moment along that orbital path. We are travelers on a long voyage we will never finish. The space between stars inside our galaxy may look empty, but it is far from simple. Clouds of gas drift for thousands of light years. Dust grains born in ancient supernova explosions float silently in the dark. Invisible dark matter forms a gigantic halo surrounding the entire galaxy. This dark matter does not emit light, and we cannot see it directly, but its gravity shapes the motion of every star. Without it, the Milky Way would fly apart. Dark matter is the hidden skeleton holding everything together. The light that reaches us from distant stars carries history with it. When you look at a star 100 light years away, the light you see left that star 100 years ago. You are not seeing it as it is right now. You are seeing it as it once was. Our galaxy is a time machine made of light. Everything we observe is a memory. Even the center of the Milky Way, which is about 26,000 light years away, appears as it existed 26,000 years before writing was invented on Earth. Every glance into the sky is a glimpse into the past. Yet as immense as the Milky Way seems, as overwhelming as its number of stars may feel, we have discovered that it is not alone. There are galaxies above us, below us, beside us in every direction. They swarm together like cities in a cosmic continent. The Milky Way is only one island in an archipelago far larger than we once imagined. When we zoom out and place our entire galaxy into context, a new story unfolds. Our home becomes not the center of everything, but a mere participant in a grander design. The Milky Way is moving too. We drift through space, pulled by the gravity of nearby galaxies. We dance in a slow-motion ballet shaped by invisible forces. Gravity is patient. It does not hurry. Over billions of years, galaxies approach each other or drift apart. Right now, we are being drawn toward a neighbor even larger than us. The great Andromeda galaxy waits in the distance, and though the space between us is vast, the pull between these two enormous spirals is relentless. When humans first learned the scale of the Milky Way, many felt humbled. But humility grows deeper when we understand that our galaxy is only one piece within a group of many. We will soon step beyond the edges of our island, and the space surrounding us will expand into something truly astonishing. The universe is layered like a nesting doll. Each layer reveals another stage where the Milky Way plays a smaller role. For now, pause and take in the idea that everything we have ever known, every story ever told, every life that has ever existed, all takes place inside this one spiral of hundreds of billions of stars. It feels impossibly large to us because it is home. But home is rarely the universe. It is simply the starting point of a much longer journey outward. The Milky Way has a story that began long before Earth formed. More than 13 billion years ago, the first stars in this galaxy ignited from clouds of hydrogen left over from the beginning of the universe. Those early stars were enormous and short-lived. They burned hot, fused heavier elements in their cores, and ended their lives in tremendous explosions that scattered their material into space. New stars then formed from the ashes of the old. Our galaxy grew through cycles of creation and destruction. Over time, it also collided and merged with smaller galaxies, absorbing their stars and dark matter into its expanding disk and halo. The night sky is a fossil record of everything that came before us. Near the center of the Milky Way lies a supermassive black hole with a mass of a few million times the mass of the Sun. It sits in the heart of the galaxy, surrounded by swirling stars that orbit at incredible speeds. This black hole is invisible to our eyes because light cannot escape it, but its gravitational influence is unmistakable. Without this object binding the central region, the inner structure of the Milky Way would look far different. Still, despite how powerful it is, this black hole is tiny compared to the rest of the galaxy around it. The Milky Way is a vast realm, where one single point of absolute darkness becomes just another detail. If we could fly upward above the disk of our galaxy, we would see that the stars form a thin pancake shape. The diameter of this structure is a little more than 100,000 light-years, but its thickness is only about 1,000 light-years in most places. This thinness reveals how gravity has pressed the galaxy into a flat, rotating plane. Around the edges, the spiral arms stretch like long ribbons, filled with young bright stars and the glowing nurseries where new suns are born. The Orion Arm, where our sun resides, contains some famous stellar neighborhoods, such as the region commonly called the Orion Nebula. These glowing clouds are sculpted by radiation and winds from hot newborn stars. They are reminders that the galaxy is alive with continuous star formation. Between the stars lies the interstellar medium, a mixture of extremely thin gas and floating dust. It looks completely empty to us, but if you imagine a volume as large as the distance between our sun and its nearest neighbor, there would still be enough particles inside to influence the birth of new stars. Some regions are dense enough to collapse under their own gravity, igniting stellar embryos. Others are cleared out by ancient blasts from supernova events, leaving cavities where starlight travels freely. The interstellar medium is quiet but restless, shaping the evolution of the galaxy in slow motion. Dark matter surrounds the Milky Way in a roughly spherical halo that extends far beyond the visible disk. We do not know exactly what dark matter is made of, but we do know how its gravity behaves. The stars in the outer regions of the galaxy move faster than they should if only visible matter were present. This strange motion revealed the existence of dark matter decades ago. Without it, the galaxy could not hold itself together. Even the space just outside the bright spiral arms is controlled mostly by this hidden mass. The Milky Way may look like a luminous wheel, yet it is really the dark halo that carries most of the weight. The motion of our sun around the galaxy happens at a speed of about 220 kilometers per second. Even at that immense speed, the journey around the center takes hundreds of millions of years. Our solar system has completed only about 20 full orbits since it formed. That means life on Earth has existed through less than one galactic year. Everything humans think of as history fits into a tiny sliver of this long cycle. The past and future movements of stars are traced by gravity, but we are here for only a fleeting moment in that dance. Most of the stars in the Milky Way are old. Some were present when the galaxy was young. They carry a record of past chemical reactions and explosions. Others are newly formed and will live for trillions of years, far longer than the universe has existed so far. Our own sun is middle-aged, about 4.5 billion years old. It shines steadily, giving Earth a chance to remain warm and stable. This is not guaranteed everywhere. Nearer the galactic center, radiation storms and intense gravitational tides make life far less likely to thrive. Our quiet location may seem ordinary, yet it is precisely the sort of place where life can take root. As we observe farther across the Milky Way, we notice patterns. Star clusters form like families, groups born together from the same cloud. Some stay connected for millions of years. Others drift apart as time passes. Nebulae glow in colors that represent different elements. Planetary systems form with a wide diversity of arrangements. Nature seems to create every possibility somewhere. The variety of worlds likely number in the tens of billions or more. The universe is generous with planets. Whether it is generous with life remains a question we are only beginning to explore. Despite the breathtaking scale of our galaxy, we have mapped only a portion of what surrounds us. Dust clouds block our view of many regions. Instruments that see in infrared and radio light can penetrate these hidden zones, revealing spirals and clusters that optical telescopes cannot detect. Step by step, we are stitching together a full portrait of our home. Yet even once we reach a clearer understanding of every corner of the Milky Way, we will still be standing inside something much larger. For the Milky Way is only a single member of a greater community, a single island in a sea that stretches outward with no shore in sight. Our place within the Milky Way is important for us, but it is only the beginning of our true address. We must zoom out again to witness the full neighborhood of our galaxy, where the gravitational influence of our stars extends into space shared with others. When we do, the story becomes even more astonishing. When astronomers first realized that the Milky Way is not the entire universe, the revelation changed everything. Our galaxy once seemed to fill all of space. Then we learned that the spiral of stars we call home is only one among an astonishing multitude. The idea that there are other galaxies was not widely accepted until a little more than 1 century ago, when telescopes improved enough to resolve faint smudges in the sky into distant star systems. Those smudges turned out to be enormous collections of stars far beyond the boundaries of the Milky Way. The universe opened wider than anyone had dreamed. From inside our galaxy, we cannot step outside and look back easily. Dust and distance blur our picture. Yet scientists can reconstruct the structure of the Milky Way by measuring the light and motion of stars in every direction. By combining that information with maps from radio and infrared observations, we can create a model of our galactic home. It is like trying to map a city while always standing inside it, but we are getting better at it. What we now see is a galaxy with a graceful barred spiral at its center, stretching outward into long arms filled with clusters and nebulae. The Orion Arm, where our sun resides, is just one thin branch in this immense structure. If you could drift above the galactic disk and look down from a great height, you would see billions of stars arranged like glowing grains of sand. The spiral arms would appear like swirling brushstrokes surrounded by vast regions of dark space. But even the dark space between the stars is not empty. Gas and dust stretch across the galaxy in delicate patterns. Some regions rise into towering clouds that eventually collapse into new stars. Others remain diffuse, slowly shaped by the energy of supernova explosions and passing shockwaves. The galaxy is both ancient and constantly renewing itself. The center of the Milky Way is a crowded and turbulent environment. Stars there move in tight orbits, influenced by the immense gravity of the central black hole. Streams of gas fall inward, heating up as they spiral closer. In this region, a single light year of space may contain thousands of stars. Radiation is intense. Collisions are more likely. Any planet in such a place would struggle against chaos. Farther outward, the spiral arms offer more peaceful environments, where suns like ours can shine steadily for billions of years. Our location is not glamorous, but it is safe. The dark matter halo surrounding the Milky Way is much larger than the visible galaxy. It extends far beyond where the last stars orbit, enveloping everything in an unseen sphere of gravity. We know dark matter is real because its influence changes the way galaxies spin. Without it, stars at the edges would drift away into space. With it, the galaxy holds together like a giant merry-go-round that never falls apart. Dark matter outweighs normal matter by several times, meaning that most of the mass in our galaxy is invisible. We exist in a universe where what we can see is only a small fraction of what is there. Our sun is moving not only around the galactic center, but also bobbing slightly above and below the plane of the disk over tens of millions of years. The stars surrounding us are moving too. Every point of light in the sky is in motion. The galaxy is a dynamic organism. Yet to our eyes, everything appears still because the timescales are far beyond human experience. If we could speed time up 1,000,000-fold, the Milky Way would look like a living whirlpool, spiraling and shifting constantly. When we consider the number of stars in the Milky Way, all the worlds that orbit them, and all the potential environments for life, the idea that we are alone feels increasingly unlikely. Even if life is rare, the sheer scale of possibilities is staggering. Somewhere among the billions of stars in our galaxy, there may be other planets with oceans, continents, and beings who have also looked up and wondered whether they are alone. The silence we hear may simply be distance. Light takes time to travel. Communication across the galaxy would require patience measured in centuries or millennia. Still, the Milky Way is only a single galaxy in a much larger structure. Once we look past its edges, we discover that our home is part of a gathering of galaxies held together by gravity. This collection, called the local group, represents the next level of our cosmic address. It is the beginning of a story where enormous systems interact with one another over unimaginable timescales. Compared to the full universe, the Milky Way is an island. But islands belong to archipelagos, and those archipelagos stretch across oceans wider than we can easily fathom. Even if we traveled at the speed of light, it would take tens of thousands of years just to leave the Milky Way and clear its outer halo. From there, the nearest major galaxy would still be more than 2 million light-years away. The distances between galaxies make the distances between stars seem tiny. We begin to understand that our galaxy, vast as it is, occupies a very small corner of the cosmic landscape. It is only when we step back to see this larger scale that a new perspective emerges. The Milky Way is not the universe. It is not even a particularly huge part of the universe. It is simply our home, and home can fool us into thinking we are bigger than we are. The story does not end here. We must zoom out again. By leaving behind the boundaries of the Milky Way, we will begin to see the true neighborhood where our galaxy lives. It is time to discover that our island is surrounded by many others, all drifting together through a far greater sea of darkness. When we cross the invisible border that marks the edge of the Milky Way's stellar disk and its extended dark halo, we do not enter emptiness. Instead, we step into a realm where other galaxies share the same gravitational territory. This is our larger neighborhood, known as the local group. It contains a little more than 50 galaxies, though most of them are small and faint. Like islands scattered across a vast ocean, they move and interact under the influence of their combined gravity, connected in ways that are subtle yet powerful. Here, the Milky Way is not alone. It has companions, rivals, and even future partners in an enormous cosmic dance. The largest members of the local group are the Milky Way and the Andromeda Galaxy. The Andromeda Galaxy is a majestic spiral like our own, but even bigger. It stretches more than 150,000 light-years across and contains perhaps 1 trillion stars. It is the heavyweight champion of our neighborhood, and its gravitational pull is strong enough that we are slowly drifting toward it. Although the space between the two galaxies is more than 2 million light-years wide, that gap is shrinking every moment. The speed at which we approach may be about 110 kilometers per second, a motion that is steady and unstoppable. In the very distant future, these two galaxies are destined to collide and merge, forming a new giant beyond anything we now call home. There are other important neighbors too. The Triangulum Galaxy, slightly smaller than the Milky Way, is the third largest member of the group. It may be gravitationally connected to Andromeda like a companion. Beyond these bright spirals are many dwarf galaxies, far more numerous than the giants. Some orbit close to the Milky Way, like the Large Magellanic Cloud and the Small Magellanic Cloud, which are visible from the southern hemisphere as glowing smudges in the night sky. These dwarf galaxies are irregular in shape, warped by tidal forces as they circle the Milky Way like small satellites. Over time, some may be torn apart and consumed by our galaxy, adding their stars to our own population. Others may survive for billions of years, orbiting like quiet wanderers. The local group is held together by gravity that acts across tremendous distances. Even though the space between galaxies contains only a few atoms scattered across each cubic meter, the mass of each galaxy influences its neighbors. The entire group spans about 10 million light-years from end to end. Inside this region, the galaxies are bound to one another so firmly that the expansion of the universe cannot pull them apart. Everything inside this boundary will remain connected forever, even as the cosmos stretches farther outward. We are part of a family that will never separate. If we could look at the local group from outside, the arrangement would appear like a loose cluster with the Milky Way and Andromeda dominating the center. The dwarf galaxies swarm around, these giants in a cloud-like distribution. Their motions are guided by complicated gravitational plays that unfold across billions of years. The space between them remains overwhelmingly dark. Stars are few and scattered. But gravity works even in the silence of emptiness, shaping what will happen far into the future. The eventual meeting between the Milky Way and Andromeda is a key chapter in our cosmic story. When they finally collide, their stars will mostly pass by one another because of the vast distances between individual stars. Collisions between stars are extremely unlikely. Instead, the galaxies will merge by redistributing their orbits, forming streams and tails of stars that swirl outward like cosmic ribbons. Gas clouds will crash together, sparking new waves of star formation. The central black holes of both galaxies will spiral inward over time, joining into an even more massive object. The final result will be a single giant elliptical galaxy, a new home formed through cosmic union. By the time this occurs, the Sun will have already grown older, and Earth's surface may no longer support life. The night sky of future inhabitants, if any remain, will display a merging blaze of stars far brighter than anything we see today. Yet this dramatic future remains billions of years ahead. For now, the local group remains stable, with each galaxy following its long path through the quiet void. The gravitational center of the group lies somewhere between the Milky Way and Andromeda, because their combined mass dominates the region. That shared motion binds the group into a single structure, separate from the rest of the universe in a physical sense. This is our nearest galactic community, a place where gravity draws members closer as time passes. As we look outward from this local neighborhood, the universe continues to expand. More galaxies appear, and their collective structure grows increasingly complex. Just as cities belong to nations, and nations belong to continents, the local group belongs to a larger arrangement in space. The gravity that holds galaxies together shapes bigger systems as well. Our group is only one cluster within a wider supercluster, a region that contains many other groups and clusters bound loosely together. Each step outward reveals a bigger map, and with each step, the importance of our individual galaxy becomes smaller. The local group may seem enormous, yet it is only a stepping stone. The true scale of the cosmos has not yet revealed itself. We have only begun to learn how galaxies gather into structures that dwarf everything we have seen so far. We stand in the suburbs of a far larger metropolis, and the journey outward will show us just how crowded the universe truly is. The galaxies of the local group are not frozen in place. They drift through the darkness, shaped by ancient events and future destinations. Many of the smallest galaxies show scars of gravitational encounters. Some have long streams of stars, stretching away like trails of spilled starlight. These are remnants of tidal forces, the slow pull that larger galaxies exert on smaller ones. When a dwarf galaxy strays too close to the Milky Way, our galaxy's gravity begins to stretch and twist it. Stars that once orbited calmly may be torn away, forming faint arcs that wrap around our spiral arms. Over billions of years, the Milky Way has devoured several small galaxies, leaving behind only faint traces. These remnants become part of our halo, like memories of meals long forgotten. The Large Magellanic Cloud and the Small Magellanic Cloud are two such companions. They are irregular galaxies with shapes distorted by tidal forces from the Milky Way. They orbit us in a long looping path, and as they do, they tug on our spiral arms, influencing star formation. Streams of gas connect them to our galaxy, hinting that one day, perhaps billions of years in the future, they may be absorbed entirely. In the sky of the southern hemisphere, these clouds appear as glowing blots, as if a painter had brushed two soft streaks of light across the night. They have guided sailors and inspired storytellers for centuries, yet their true nature was misunderstood until recently. They are not clouds at all. They are neighboring galaxies in motion. Even smaller dwarf galaxies lurk on the edges of the local group. Many are so faint that they are barely visible, even to powerful telescopes. Some contain only a few million stars. Others are little more than clusters of dark matter with a sprinkling of light. Their survival depends on distance. Those too close to larger galaxies risk destruction. Those farther out drift quietly in the loneliness of space, unperturbed by their powerful neighbors. Each dwarf galaxy carries clues to the earliest days of cosmic history, because their stars are ancient and their growth slowed long ago. By studying them, we learn how galaxies formed and how the first stars shaped their surroundings. The local group has a center of gravity that everything within it slowly orbits. Though the space between galaxies feels empty, their paths are curved by mutual attraction. Over unimaginable spans of time, galaxies shift positions, spiraling toward the deepest well of gravity. The Milky Way and Andromeda are like two great ships drawn toward one another by a silent current. Eventually, they will meet. Though that meeting is peaceful in the sense that stars rarely collide, it will still be a violent reshaping of both galaxies. Their spirals will warp and tear. Their stars will be thrown into new orbits. Their central black holes will unite. Out of destruction, a new single structure will be born, larger and rounder than either parent. What we call the Milky Way will vanish, replaced by a new galaxy with a new identity. The space outside the local group may seem disconnected, but it is not. Beyond our borders lies a grander structure, the Virgo supercluster, which draws the local group toward its center. Gravity binds together not only single galaxies, but groups of them. The local group is one neighborhood in a cosmic city of unimaginable scale. When we look at maps of nearby galaxies, we see patterns. Galaxies gather near one another in clusters. Clusters gather into larger formations. These structures are not random. They follow the invisible scaffolding of dark matter that threads the universe like a skeleton made of pure gravity. In the local group, distances are so large that even communication seems impossible. Suppose a signal left Earth traveling at the speed of light. It would take more than 2 million years for that message to reach Andromeda. Any reply would require another 2 million years to return. Civilizations separated by such distances would never converse in real time. For all practical purposes, they would be forever silent to one another. This helps explain the cosmic quiet we experience. The universe may be filled with life, but distance is a barrier stronger than any wall. Even so, we study our neighbors. We trace their shapes, measure their motions, and predict their futures. The local group is our immediate cosmic context, and understanding it helps us place ourselves more accurately within the universe. We are not isolated. We are part of a dynamic cluster filled with activity and change, even if that change happens at a pace too slow for human eyes to notice. One day, far beyond the lifespan of our planet, the sky above any surviving observers in our galaxy will transform. Andromeda will swell from a faint smudge into a sweeping spiral larger than the Moon appears today. Stars from both galaxies will mingle. The night will glow with new points of light. Eventually, the sky will be radically altered, with no clear distinction between what once were two separate galaxies. A new cosmic identity will have formed. Yet to those future beings, whatever shape their existence may take, it will simply be home. We now stand ready to zoom farther outward. The local group itself is part of a grander assembly, a structure that extends across distances that reduce even our galaxy to a tiny flicker. Beyond our small collection of galaxies lies a region filled with thousands more. The next step outward reveals that our neighborhood is only a minor district in a vast supercluster. Galaxies in the local group appear lonely at first glance, separated by millions of light years. Yet they are not drifting aimlessly. Everything inside this region is moving as part of a deeper flow. The Milky Way and Andromeda, along with the smaller galaxies surrounding them, are journeying together towards something far larger. Space itself is expanding, stretching the distances between the most distant galaxies in the universe. But inside the local group, gravity has already won the battle against expansion. These galaxies are locked together forever, destined to influence one another until the end of time. If we imagine the cosmos as a grand landscape, then the local group is a small valley. The walls of this valley are shaped by gravity. Galaxies will never climb over them. Any galaxy that wanders near the local group will be captured by its gravity and drawn inward. Any galaxy that moves too fast may escape, but very few have that speed. Over many billions of years, more and more small galaxies may join the group as they drift closer. The local group will grow, even as the larger universe stretches farther and farther away. Already we see clues that our surroundings extend into something enormous. When astronomers map the positions of galaxies beyond the local group, they see that our group is only a tiny component of a greater structure. This larger system, which pulls us gently toward its center, is known as the Virgo supercluster. Although the boundary between the local group and the surrounding regions of space is not sharp, we can identify the area where our group's gravity gives way to the influence of other collections of galaxies. Beyond that threshold, gravity begins to gather galaxies into more complex shapes. Threads, filaments, and clusters emerge as if the universe were weaving a cosmic tapestry. The local group is small in comparison to the immensity beyond. we can think of the Milky Way as a house. The local group is the neighborhood. The Virgo supercluster is the city. When we travel outward mentally from one scale to the next, our sense of size and importance shrinks again. The local group, which once felt large compared to the Milky Way alone, becomes tiny when compared to the supercluster waiting ahead. And just like neighborhoods in a city, galaxy groups are not identical. Some are richer, packed with dozens of large galaxies. Others are sparse. The local group belongs to the quieter suburbs, far from the busiest intersections of cosmic structure. Even though the local group spans many millions of light years, it does not contain many luminous galaxies. Most are faint dwarfs, barely visible even with powerful telescopes. These small galaxies play crucial roles in shaping the architecture of the region. They add mass, stir the gravitational currents, and act as messengers from the early days of galaxy formation. Some dwarf galaxies are relics of ancient collisions, fragments of once larger galaxies dismantled and consumed. Others may be survivors from the earliest cosmic times, untouched by mergers or violent interactions. Within this quiet but bound collection, time moves on a scale that defies human measurement. What we call history is the blink of an eye. The stories that unfold here involve billions of years. Stars are born and die while galaxies slowly change their relationships. The anticipated collision with Andromeda lies so far ahead that every continent on Earth will have shifted and transformed countless times by the moment that event begins. Yet cosmic events do not require witnesses. They unfold regardless of who is watching. To understand where and we truly live, we must continue stepping back. The local group is our immediate home in the universe, but like every home, it rests inside something greater. Our group belongs to a supercluster made up of thousands of galaxies, a region with a gravitational identity stretching across more than 100 million light-years. It is within that larger environment that our local group finds its place among many others. We are now prepared to leave our neighborhood and explore the vast metropolis beyond. The Virgo supercluster awaits, and what we find there will make even the local group seem impossibly small. Our home continues to shrink as our perspective expands. When we drift beyond the edges of the local group in our imagination, we do not find a uniform emptiness. Instead, we begin to see clusters of galaxies arranged like neighborhoods in a sprawling cosmic city. Our local group is only one such community, and farther outward, we discover we are part of a far larger region known as the Virgo supercluster. This structure contains thousands of galaxies spread across a space more than 100 million light-years wide. It is difficult to picture such scale. Even the entire Milky Way, with its hundreds of billions of stars, becomes a minuscule speck on this map. The Virgo supercluster is dominated by a massive collection of galaxies at its center, called the Virgo cluster. This central hub contains more than 1,000 galaxies on its own. Some of them are so large that they make the Milky Way appear small by comparison. This cluster is like the bustling city center of the supercluster, a place crowded with activity and shaped by powerful gravitational forces. Galaxies there move rapidly, bound together in a chaotic ballet, driven by the hidden mass of dark matter. Collisions between galaxies are far more common in such dense environments. Stars and gas are torn apart and reorganized, creating new shapes and new generations of stars. Our local group lies far from this crowded region, in one of the quieter outskirts of the Virgo supercluster. We reside in the suburban fringe, separated by tens of millions of light-years from the vibrant heart of the cluster. Yet we are still influenced by its gravity. The entire local group is slowly falling toward the Virgo cluster, drawn in by the combined mass of all those galaxies. Although the distance is so immense that even light requires many millions of years to cross it, the pull is undeniable. Gravity works patiently. What it begins today may only reach completion in billions of years, but it never relents. When scientists mapped the Virgo supercluster, they discovered that it is not merely a simple cluster of galaxies. Instead, it is a complex structure filled with streams and walls of galactic systems. These structures trace the shape of the invisible dark matter that threads the universe. Where dark matter is dense, galaxies collect together. Where dark matter is sparse, cosmic voids appear. The Virgo supercluster resembles a web more than a simple spherical cluster. The local group is one bright node in this cosmic web, connected to others through the subtle flow of gravity. Some of the galaxies in our supercluster are giant ellipticals, which formed when smaller galaxies merged in violent encounters. Others are spirals like the Milky Way, still maintaining their graceful rotating arms. Many are tiny dwarf galaxies scattered throughout space, too faint to be easily noticed. Together, these galaxies form a family bound not by physical contact, but by shared influence. The Virgo supercluster is like a country whose borders are marked by gravitational reach, rather than political agreements. The space inside this supercluster is still mostly empty compared to the size of galaxies, but on cosmic scales, the emptiness is relative. There are regions filled with hundreds of galaxies within the span of a cluster, followed by vast dark voids stretching for millions of light years. The contrast is like finding a single bustling city surrounded by enormous plains where nothing seems to live. And yet, even the darkest regions are not truly empty. They hold dust, gas, stray stars, and the ever-present dark matter that forms the skeleton of the universe. This realization changes our perspective again. The Milky Way is tiny within the local group. The local group is tiny within the Virgo supercluster. At each step outward, we become less central and less significant in terms of size. It is not a story that diminishes us. Rather, it expands our understanding of where we truly belong. We are part of something immeasurably grand, a cosmic structure built by the subtle interplay of gravity over billions of years. Despite the enormous scale of the Virgo supercluster, it is still not the final layer of structure. It turns out that what we once thought was the full extent of our cosmic address is only a fraction of a far greater system. There is another level of organization beyond this supercluster, something that redefines how these galaxies truly move through the universe. The Virgo supercluster is just one tributary in a much larger flow. To see the true shape of our home, we must zoom out once more. As astronomers pushed their observations farther and farther beyond the local group, they noticed that the galaxies in our region were not simply drifting randomly. They were moving together, flowing in a collective direction, as though pulled by a distant gravity well. The Virgo supercluster is not truly a single self-contained island in space. Instead, it is part of a larger pattern, a deeper river of motion that extends far beyond the 100 million light-year span we once believed defined our home. This realization showed that the Virgo supercluster was only a stop on the journey outward, not our final address in the cosmos. Within the Virgo supercluster, galaxies are arranged in threads rather than evenly. These threads form long chains that stretch across unimaginable distances, linking clusters into larger shapes. Between these chains lie enormous voids, regions where almost no galaxies exist. These voids can span tens of millions of light years without a single major star system to brighten the darkness. If the Virgo cluster is the bustling city center and the local group is a quiet suburb, then the voids are like vast oceans that separate continents of light. They highlight just how unevenly matter was distributed when the universe formed. Gravity sculpted the early universe like a potter shaping clay, pulling matter into strands and leaving hollows in between. The galaxies inside the Virgo supercluster also share a common destiny. They are falling toward the central Virgo cluster, following a path shaped by the mass of the cluster and the surrounding dark matter. Over billions of years, galactic orbits will change. Some groups may spiral inward, others may skim the outer boundaries forever. The local group will continue its slow descent toward the supercluster's heart. But that journey will take longer than the sun will shine. Our star will fade long before our galaxy reaches the crowded center. Because of these immense timescales, it is easy to imagine the Virgo supercluster as frozen in place. But every galaxy is in motion. Even clusters evolve, colliding and merging as time progresses. The Virgo cluster itself is the product of many smaller clusters drawn together across cosmic history. Some of its galaxies have grown huge by consuming their neighbors. Others have been stripped of gas, unable to form new stars. Life in the heart of a massive cluster is harsh. The heat of the surrounding gas can cook star-forming clouds until they evaporate. Only the most resilient galaxies continue to grow. Observing the Virgo supercluster requires mapping space with many types of light. Radio telescopes reveal clouds of cold hydrogen gas. Infrared telescopes expose galaxies hidden behind dust. X-ray telescopes highlight the hot plasma that fills the space between galaxies in dense clusters. By combining these tools, astronomers create a portrait of a structure too vast for any single method to capture. We must stitch together every wavelength of light to understand the architecture of the cosmos around us. All of this leads to a deeper truth. The Virgo supercluster is not a separate entity with clear boundaries. Instead, it fades gradually into even larger structures that shape the flow of galaxies over hundreds of millions of light years. Our supercluster does not stand alone. It is part of a greater network where gravity gathers entire regions of space into coherent forms. The limits of the Virgo supercluster are not the limits of our home. Beyond it lies something even more breathtaking. This greater structure was not clearly recognized until very recently in human history. Scientists began to notice that the Virgo supercluster is only one part of an enormous basin of attraction, a region where galaxies flow like water in a vast cosmic watershed. By measuring the motion of thousands of galaxies, they discovered that all of them are falling toward a common gravitational center, a region sometimes called the Great Attractor. This strange phenomenon hinted that we belong to something much larger than the Virgo supercluster. It would take new methods of mapping motion through space to reveal the true shape of this greater home. When that map was finally built, it showed a structure so immense that it redefined our place in the universe. The Virgo supercluster, once thought to encompass everything around us, became only a fraction of a structure with more than 100,000 galaxies. That structure would be given a name that captures the scale of its influence and the unity of everything within it. To know where the Milky Way truly resides, we must zoom out again. The next step in our journey outward will reveal the real borders of our cosmic address. We will discover that we are part of a gravitational nation far grander than the Virgo supercluster itself. Even within the Virgo supercluster, the galaxies are not scattered without purpose. Their motions reveal a story of hidden structure. When astronomers chart how the galaxies move, they see that all of them, including our own Milky Way, are flowing toward a particular region of space. This is not a simple drift. It is a collective migration, as though the galaxies were leaves floating along a current in a river far wider than we once understood. The river is made not of water, but of gravity itself, pulling everything through the cosmic landscape. For a long time, this strange flow puzzled scientists. The motions did not match what would be expected if the Virgo supercluster were the full source of gravitational influence. Something beyond it was affecting our path. The pull was coming from a direction that led deeper into space, toward an unseen region of enormous mass. This mysterious source came to be known as the Great Attractor. Although the name sounds like science fiction, it reflects a real phenomenon. The galaxies around us are being drawn toward a massive gravitational depression, a kind of valley in the fabric of space. The Great Attractor itself is hidden behind thick layers of dust and stars in the plane of the Milky Way, a region sometimes called the zone of avoidance, because visible light cannot easily pass through. But other forms of light, such as infrared and radio waves, can penetrate this obstruction. By studying those wavelengths, astronomers detected a large concentration of galaxies that lie beyond our direct view. These galaxies add their mass to the pull we feel, helping explain why our entire section of the universe is moving as one great migrating superstructure. Yet, even the Great Attractor does not tell the full story. As observational techniques improved, researchers discovered that the flow of galaxies extends even farther, guided by a shape larger and more intricate than the Virgo supercluster. Galaxies are not merely being pulled toward a single point. They are sliding down the slopes of a massive gravitational basin, funneled along branching corridors that connect many clusters together. It is as though the universe were composed of enormous valleys and ridges formed by dark matter, with galaxies moving through the lowlands according to the rules of gravity. Eventually, scientists realized that what we once called the Virgo supercluster was simply one lobe, one component of a far grander system. The true structure encompasses more than 100,000 galaxies, arranged across a volume about 520 million light-years wide. Everything within this space flows toward a shared basin, a gravitational destiny linking galaxy to galaxy, like raindrops running toward the same ocean. When this extraordinary revelation appeared in the early 21st century, astronomers understood that they had uncovered the real boundaries of our extended home. The name given to this colossal structure is Laniakea, a word from the Hawaiian language that means immeasurable heaven. The name reflects both its scale and its beauty. Laniakea redefines our cosmic address. The Milky Way is only one tiny spark inside a structure so vast that human minds struggle to comprehend it. Within Laniakea, superclusters like Virgo are not isolated. They are interconnected like neighborhoods inside a single continent of galaxies. The local group, which once felt so enormous, now becomes a microscopic thread woven into a tapestry more immense than anything humanity imagined for most of its history. Understanding that we belong to Laniakea offers a profound shift in perspective. The gravity that shapes our journey through space does not stop at the borders of the Virgo supercluster. It extends outward into a network of galaxies that form the true pattern of matter surrounding us. We are not sitting still in the universe. We are plunging forward with every other galaxy in Laniakea, caught in a slow and silent river of motion that has been flowing for billions of years. Now, when we gaze out from the Milky Way and trace our path through the local group and beyond into the Virgo supercluster, we see that we were still looking too close. To truly appreciate the scale of existence, we must recognize that our home extends into a gravitational nation, with borders so wide that even light requires hundreds of millions of years to cross from one edge to the other. And yet, astonishing as this is, Laniakea is still not the final structure of the universe. It touches other structures at its edges. It connects to filaments that stretch into deeper and darker regions of space. What we once thought of as the universe, filled with scattered galaxies, has revealed itself to be something far more organized. The cosmos has a skeleton, a pattern of filaments and voids. The Milky Way rides along those filaments like a single grain of sand traveling down a thread in a colossal web. To uncover the next layer, we must step back even farther still. Our island in the stars belongs to a vast archipelago. Our archipelago belongs to a continent, and that continent is part of a web stretching to the limits of what we can observe. When the discovery of Laniakea was first announced, it transformed our understanding of where we live. The address we thought we knew was incomplete. We had believed that the Virgo supercluster defined the full extent of our cosmic surroundings, but the truth is far more astonishing. Laniakea revealed that what we once called a supercluster is only one district in a much greater realm. The Milky Way, the local group, the Virgo supercluster. All of these are simply smaller components of this vast gravitational domain. Laniakea stretches across space for about 520 million light-years, containing more than 100,000 galaxies. That scale is so enormous that even our supercluster becomes a tiny spark inside it. To understand what Laniakea is, Imagine the universe as a landscape shaped by invisible gravity. The galaxies are like rivers flowing down gentle slopes into valleys, drawn toward regions of deeper gravitational influence. Those valleys are not simple pits, but sprawling basins that collect galaxies from afar. Laniakea is one of those enormous basins. Everything within it flows toward the center of gravity, near a region once called the Great Attractor. The movement is slow, measured over billions of years, but the direction is unwavering. Our galaxy is on that journey, whether we feel it or not. The name Laniakea means immeasurable heaven, and it reflects both the breathless beauty and overwhelming scale of this discovery. Galaxies that once seemed independent are now understood as participants in a shared motion. Every star in the Milky Way, including the Sun, drifts through Laniakea, along a path guided by gravity we cannot directly see. Space is expanding overall, yet within this vast basin, gravity binds the galaxies closely enough that they resist that expansion. They remain dancers in a choreographed motion across the dark cosmic floor. Mapping Laniakea required a method far more subtle than measuring positions on a map. Scientists studied the peculiar velocities of galaxies, which means the parts of their motion not caused by the expansion of the universe. By analyzing how galaxies deviate from the general outward drift of cosmic expansion, astronomers could trace the direction of gravitational flow. These motions revealed threads of movement converging on the region influenced by the Great Attractor. The boundaries of Laniakea were defined not by where galaxies sit in space, but by where they are headed. Everything flowing toward the same basin belongs to Laniakea. Everything moving away belongs to neighboring basins. This idea is similar to how raindrops falling on a mountain end up in different rivers depending on which slope they land on. The raindrop does not know the final destination when it falls, but its path will inevitably lead it toward one watershed or another. The galaxies in Laniakea are like those raindrops. They follow the unseen gradients of space, their futures determined by the contours of gravity. Our Milky Way is part of the river that leads into the heart of Laniakea. Laniakea is not the only such structure. Beyond its borders lie other vast gravitational nations. Each one is connected to the next through delicate filaments of galaxies that stretch across unimaginable distances. These filaments form the cosmic web, the largest pattern in the universe. At the edges of Laniakea, the flow of galaxies shifts direction, forming boundaries much like shorelines separating one watershed from another. But unlike ordinary borders, these divisions are not fixed. Over billions of years, flows can change, structures can merge. The universe is not a static picture, it is alive with motion. One of the most fascinating aspects of Laniakea is how it reveals our insignificance in terms of size, while simultaneously reminding us of our connection to something unimaginably large. The Milky Way is one galaxy among hundreds of billions in the observable universe. Inside Laniakea alone, it is just one of more than 100,000. Even the supercluster that once seemed so vast is merely a district inside this grander territory. And yet, our tiny place inside this enormous structure gives us a unique vantage point. We are observers capable of understanding the architecture of the cosmos that contains us. The journey of our galaxy through Laniakea is not something we can witness in a human lifetime. The speed and scale are too vast for us to sense. But just as Earth moves around the Sun without us feeling the motion, the Milky Way moves across Laniakea without any sensation. We are passengers inside a star system, inside a galaxy, inside a gravitational river flowing through a basin that is nearly beyond imagination. Knowing that we belong to Laniakea reshapes our cosmic map. It expands our identity, but it also raises a profound question. If Laniakea is only one structure among many, what lies beyond its edges? How do these immense basins connect into even larger shapes? What is the true extent of the cosmic web that supports them all? To answer that, we must zoom out once again, because even Laniakea, for all its immensity, is not the full story of how matter is organized at the largest scales. It is only one chapter in a universe still growing, still stretching, and still filled with mysteries far deeper than anything we have yet uncovered. Inside Laniakea, galaxies move like travelers along intertwining roads. Each one follows a slow descent, guided by gravity. Even though the universe expands overall, pulling the most distant galaxies away from one another, the regions inside gravitational basins remain connected. Here, the pull inward is stronger than the push outward. That is why the galaxies of Laniakea will remain neighbors for the rest of cosmic time. They are companions on a shared voyage through the immeasurable darkness. The heart of Laniakea is a region of intense gravitational influence near what astronomers once called the Great Attractor. The term Great Attractor describes not a single object, but a deep gravitational valley created by the combined mass of many clusters of galaxies. These clusters and the dark matter they contain act together like a mountain of gravity. The Milky Way, the local group, and countless other star systems are sliding toward that region slowly but surely. This motion is not something we can feel. There is no breeze to indicate our movement. Yet measurements show undeniably that our galaxy is being drawn inward like a leaf on a silent current. This gravitational flow gives shape to the borders of Laniakea. Instead of lines drawn on a map, the boundaries are defined by where galaxies are headed. If a galaxy flows toward the same gravitational center as the Milky Way, then it belongs to Laniakea. If it flows away toward a different center, then it belongs to another cosmic domain. The universe is divided not by static walls, but by motion. It is a rare moment in history that humans can even attempt to chart such things. For most of our existence, we believed the sky was fixed above us. Now we know everything in the heavens is moving with purpose. Within Laniakea, superclusters like Virgo are linked by long filaments that stretch across hundreds of millions of light years. These filaments contain strings of galaxies aligned along invisible threads of dark matter. They are the highways of the cosmic web. At the intersections of these threads, clusters form naturally where gravity gathers matter most strongly. The Virgo supercluster is one of those intersections. The Milky Way is far from its dense core, but the influence still reaches us. Along these threads, galaxies migrate, slowly approaching the deeper regions of gravitational pull. The discovery of Laniakea gave us a new way to understand the structure of the universe. It is not a random scattering of galaxies. It is a network shaped by the earliest ripples in the fabric of space and time. The pattern resembles neurons in a brain or the filaments of a deep-sea creature. This similarity is poetic rather than literal, yet it reminds us that complexity emerges on every scale of nature. The universe is the largest known expression of order, born from the simplest initial conditions. We can only observe a fraction of Laniakea. Most galaxies are too faint or too distant to study individually. Many lie behind thick walls of dust when seen from the Milky Way. But the motions of those we can see allow us to infer the paths of those we cannot. It is as if we watch floating leaves and from their movement learn the shape of a river we cannot yet fully map. Every new observation adds detail to this invisible geography. Even at this immense scale, there are mysteries. The combined mass of the galaxies visible inside Laniakea cannot fully explain the powerful pull we experience. Dark matter, which outweighs normal matter by several times, must fill in the gaps. The very structure that defines Laniakea would collapse without this hidden substance. We live in a universe where most of what exists is something we cannot see directly. Our home is shaped by ghosts of gravity that silently guide everything. The concept of home takes on a new meaning when viewed from this perspective. We are not simply residents of a planet. We are not merely citizens of a star system. We are members of a galaxy that belongs to a galactic group, which belongs to a supercluster, which itself resides inside a basin of gravity so large that even light needs hundreds of millions of years to cross it. That is our address in the universe. Earth, the solar system, the Milky Way, the local group, the Virgo supercluster, Laniakea. Each level of structure makes the previous one feel smaller, yet also more connected to something magnificent. However, even Laniakea is not the ultimate scale of structure in the cosmos we can observe. Beyond its flowing edges, other basins exist with their own attractors pulling galaxies in different directions. The boundaries of these gravitational nations touch each other in a grand latticework. The next step outward will reveal how Laniakea itself fits into the cosmic web, the largest structural pattern the universe has ever created. On the outer edges of Laniakea, the gravitational flow shifts. Galaxies that travel along its filaments may eventually reach a crossroads, where the pull of a different region becomes stronger than the pull of the great attractor. These crossing points define the boundaries between the immense basins of the cosmic landscape. They separate one gravitational nation from another. Beyond those borders lie superclusters that are not part of our journey inward. They follow their own paths, drawn to different centers far across the darkness. This interconnected network of basins forms what astronomers call the cosmic web. Laniakea is only one branch of this web, united through delicate threads of galaxies. On larger scales, these threads weave into walls of structure that stretch for hundreds of millions of light years. Between those walls lie voids where almost no galaxies exist. The contrast is extreme. In the densest clusters, thousands of galaxies crowd into a single region. In the voids, light travels for tens of millions of years before it encounters even a single island of stars. The universe is a landscape of abundance and emptiness interwoven. It is astonishing to realize how much of the cosmos consists of nothing at all. Even inside Laniakea, galaxies are like scattered lanterns floating in a gulf of darkness. The distances between them are so vast that each galaxy lives in isolation most of the time, unaware of its neighbors except through the subtle pull of gravity. Light must travel for millions or hundreds of millions of years to cross the spaces that separate clusters within our supercluster. And yet, thanks to our instruments, we are able to observe this grandeur from a small planet orbiting a modest star. The universe did not always look like this. In the early stages of its history, matter was spread more evenly. Tiny variations in density emerged as the universe expanded and cooled. Those small differences acted as seeds for future structure. Over billions of years, gravity pulled matter together into filaments, clusters, and superclusters. Laniakea is one such result of that long evolution. The shape of our home was written in the faint ripples that filled the cosmos soon after the beginning of time. Although Laniakea appears stable on human timescales, it is not a permanent structure. The expansion of space continues to drive galaxies apart on the largest scales. In far distant futures, gravitational basins like Laniakea may become the final islands of structure in an otherwise unreachable universe. Galaxies outside these basins will recede beyond the horizon, forever lost to view. The cosmic web that now surrounds us will slowly fade as its distant filaments stretch away faster than light can keep them visible. The future of structure is isolation. In time, only the gravitationally bound systems inside Laniakea may remain connected. Even now, we are living in a fortunate moment when the cosmic web is visible to us. We can trace its enormous filaments across hundreds of millions of light years. We can see how galaxies line up along the skeleton of dark matter. We can recognize our place within a structure that is too large to fit into the imagination, yet real enough that we can measure its dimensions. It is a testament to human curiosity that from our small vantage point, we have discovered that our galaxy flows along a river that is itself part of a vast ocean. And yet, the scale continues to grow. Even Laniakea, for all its immensity, fits within a network of structures that extend to the limits of what we can observe. The cosmic web spans the visible universe, connecting billions of galaxies into one continuous architecture. It is the ultimate expression of how gravity shapes matter on the largest possible scales. So we continue our journey outward. We have traveled from a planet to a star, from a star to a galaxy, from a galaxy to a group, from a group to a supercluster, and now from a supercluster to an even larger gravitational basin. Each step has revealed a surprising truth. What feels enormous from up close is only a fragment of something greater. Now, it is time to move beyond Laniakea's boundaries and look at the universe as a whole. The larger structures that contain us are waiting to be explored. Ahead lies the full cosmic web, a network so vast that even Laniakea becomes only a minor detail in its design. The farther we step outward from our galaxy, the more the universe reveals its astonishing design. What once looked like a scattered collection of stars and galaxies becomes a pattern shaped by the deepest laws of nature. On this immense scale, galaxies are not placed randomly. They gather along enormous tendrils that stretch across hundreds of millions of light years. These tendrils are called filaments, and together they form the cosmic web, the largest structure ever discovered. It is a network so vast that even the imagination struggles to comprehend its reach. The Milky Way, which once felt like the entire cosmos, becomes a barely noticeable spark hanging on one tiny thread of this immeasurable structure. The cosmic web is woven from normal matter and from the invisible dark matter that outweighs all the stars and planets we can see. Dark matter does not shine and cannot be touched, yet it shapes the universe like a hidden architect. Its gravity collects gas and stars into long strands. The filaments stretch across space like the beams inside a gigantic cathedral, while the galaxies cling to them like dust drifting along the pillars of a colossal structure. Without dark matter, there would be no filaments, no clusters, no galaxies, and certainly no life. We owe our existence to gravity generated by something we do not yet understand. Between the filaments lie voids. These voids are not small pockets of emptiness, but enormous regions that may span 100 million light-years or more, where hardly any galaxies exist. If you could travel into one of these voids, the night sky would be almost completely dark. A distant galaxy might appear as a faint, nearly invisible speck if it could be seen at all. These cosmic deserts are as important as the filaments themselves. They represent the places where matter did not gather, where gravity lost the contest against the expansion of space. In some ways, the voids define the web as strongly as the filaments do. Light reveals the clusters and threads, but darkness reveals the spaces between them. The formation of the web began when the universe was young. Soon after the beginning of time, the cosmos was almost smooth, with only tiny differences in density. But gravity amplified those tiny differences. Slightly dense regions pulled in more gas, becoming denser still. Slightly empty regions lost material, becoming even emptier. Billions of years later, those faint ripples grew into a colossal structure with walls and tunnels larger than any planet, star, or galaxy could ever hope to be. The cosmic web is a fossil of the first whispers of structure imprinted on the universe before stars were born. When we map the web, we are decoding the earliest memories of the cosmos. Inside the filaments, entire families of galaxies move like ships drifting along invisible currents. The Milky Way and its neighbors in the local group are part of one such current. We follow a winding path through space guided by gravitational slopes of dark matter. The filaments are not straight lines. They twist and curve, connecting clusters together through long winding routes. Where two or more filaments meet, enormous clusters form. These clusters contain thousands of galaxies bound together by gravity. Some are calm and ancient, while others are violent and chaotic, slamming galaxies into one another and forging new shapes from the wreckage. If we could zoom out far enough to see the universe as a whole, the cosmic web might resemble the tangled branches of a tree or the neural network inside a living mind. The similarity is poetic, even if the underlying physics is different. The universe is not alive, but its structure appears alive with connectivity. Each galaxy is a shining node in a grand network. Light travels along these connections like thoughts passing between neurons. This resemblance invites reflection. From the smallest particles to the greatest superstructures, complexity emerges naturally. Nature builds patterns on every scale. Our own location in this vast network is quiet compared to the busiest intersections. We are not near a giant central cluster. We are not in the blazing core of a crowded filament. Instead, we live in a calmer segment on the outskirts, guided by the pull of the Virgo cluster and the deeper gravitational basin of Laniakea. Yet even here, the influence of the cosmic web is felt. The motion of our galaxy, the flow of the local group, the path of the Virgo supercluster, all follow the grand lines drawn by the web. We are not traveling alone. We are part of a migration that spans hundreds of millions of light years. The voids around us remind us of the sheer scale of emptiness in the universe. Matter is rare. Space is vast. Even the filaments themselves are mostly empty, with galaxies spaced so far apart that communication between them would require millions of years. The distances make even the closest cosmic relationships feel lonely. When we look up at the stars, we see a sky full of lights. But compared to the universe as a whole, those lights are only scattered pockets of brilliance suspended inside an ocean of near-perfect nothingness. Darkness dominates the cosmos. Light is the exception, yet the presence of the cosmic web gives the darkness context. It is not random nothingness. It is a structure waiting to be understood. Astronomers have tracked the positions of hundreds of thousands of galaxies to reveal the threads and clusters near us. They have measured how galaxies move to determine the flow of gravity along the web. They study faint gas inside the filaments glowing softly in ultraviolet light. They observe high-energy rays streaming from galaxy clusters where collisions heat the gas to temperatures hotter than the cores of stars. Every observation uncovers another piece of the web's hidden complexity. The voids are also studied. Some voids contain a few lonely dwarf galaxies, drifting like boats lost at sea. Their isolation makes them valuable laboratories. They evolve without interference from larger galaxies. Their stars may preserve information from the earliest epochs of the universe. In these dark regions, we find secrets that cannot be uncovered in the bustling clusters where gravitational chaos reshapes everything. Even emptiness holds knowledge. The cosmic web stretches all the way to the edge of the observable universe. Its filaments define the skeleton upon which every galaxy rests. Even the most distant smudges in the night sky follow the same pattern. This unity suggests that the laws of physics are the same everywhere that light can reach. A galaxy, billions of light years away, follows the same rules as the Milky Way. Gravity binds both to structures too vast for any one life form to witness fully. The web transcends scale and perspective. It binds together the entire visible cosmos. The farther we look along the filaments, however, the more we encounter something even more astonishing. The web contains structures so large that they challenge what we once believed about the universe. Some of the filaments join to form colossal walls where galaxies stretch across billions of light years. These walls are among the largest coherent structures ever discovered. Their existence raises profound questions. How could something so large form from the tiny seeds of density present in the early universe? How does the web grow such giants while still obeying the principle that the universe should look roughly similar in every direction? One of these structures is known as the Sloan Great Wall, a chain of galaxies extending for billions of light years. Another is the Hercules Corona Borealis Great Wall, which spans a distance that seems to push the boundary of what cosmologists predicted could exist. These immense forms are rare but real. They show that the universe can build architecture at scales once thought impossible. When we first learned about galaxies, we imagined them as standalone islands. Now we know that they are bricks in walls that stretch farther than light has fully had time to travel since their formation. The cosmic web is not just beautiful, it is humbling. It reveals a universe that is both grand and indifferent. We are a single civilization living on a small planet, orbiting a fairly ordinary star in an average arm of a modest galaxy, which itself hangs on a thread inside a structure that dwarfs imagination. The web reminds us that significance does not come from size. We are small, but we are capable of seeing the truth of where we live. That awareness is its own form of greatness. As we prepare to step outward again, we must pause and reflect on our journey so far. We began on a planet. We expanded to a solar system, then to the Milky Way, then to the local group, then to the Virgo supercluster, and then to Laniakea. Now we stand inside the cosmic web, the ultimate map of structure in the observable universe. Each level of zoom has revealed that our home is smaller than we once believed, and yet each revelation has also shown that we belong to something astonishingly vast. The universe is a masterpiece of scale. Ahead of us lie the giants, the greatest walls of matter ever discovered. The cosmic web is the framework, but the walls are its most awe-inspiring features. They stretch so far that even speaking their lengths forces us to confront the limits of language. The next chapter will carry us into their shadow. There we will discover how truly tiny our Milky Way is when compared to the largest structures known. When we step deeper into the cosmic web, the scale of structure grows until even the filaments can no longer contain what the universe has built. In certain regions, galaxies do not merely line up in threads. They gather in colossal sheets that stretch for billions of light years. These are cosmic walls, the largest structures ever observed in the visible universe. Their sizes defy ordinary understanding. They are so vast that if you could travel at the speed of light, you would spend billions of years just moving from one side to the other. These walls are the true titans of existence. Compared to them, the Milky Way becomes so small that calling it a grain of dust feels like exaggeration. It is less. It is a microscopic fleck resting on one tiny corner of a structure that spans nearly a tenth of the observable cosmos. One of the first major discoveries that revealed these giants was the Sloan Great Wall. When astronomers created large three-dimensional maps of galaxies using data from the Sloan Digital Sky Survey, they uncovered a formation stretching across more than 1 billion light-years. Imagine a chain of galaxies so extensive that light requires a time longer than the emergence of multicellular life on Earth to cross it. That is the scale of the Sloan Great Wall. It is not a single object, but a sprawling arrangement of clusters and filaments linked together in a continuous tapestry. It was a revelation that the universe contains patterns larger than anyone had imagined before. Even that enormous structure does not hold the record. A different formation, found in the direction of the constellations, Hercules and Corona Borealis, extends even farther. Astronomers call it the Hercules-Corona Borealis Great Wall. The name is simple, but its reality is not. This structure is so gigantic that it may stretch nearly 10 billion light-years from end to end. That number challenges the very foundation of cosmology. According to standard theory, the universe should appear uniform on the largest scales, meaning no structure should exceed a certain limit. The existence of a wall this large raises questions about how the universe grew and whether we truly understand the full picture of its evolution. These walls are so immense that they influence the motion of galaxies far beyond their visible borders. Their gravitational presence shapes the flow of matter along the cosmic web. They are like the mountain ranges of the universe, rising from a landscape carved by dark matter. Filaments feed into them like valleys leading to towering peaks. Clusters pile up along their ridges, forming bright knots of starlight. The voids on their far sides are like deep oceans where almost nothing survives. The contrast between these crowded walls and the silent emptiness beside them is among the most striking features in all of cosmic structure. Understanding how such massive structures formed requires looking back to the earliest moments after the beginning of time. Tiny fluctuations in density imprinted on the universe when it was still less than a second old eventually grew into the cosmic web. Those fluctuations acted as seeds. Over billions of years, the gravitational pull of matter caused the dense regions to collapse and stretch into long filaments, which then collided to create enormous planar structures. Even so, the scale of the largest cosmic walls pushes this explanation to its limits. They are so big that some scientists wonder whether unknown physics was involved, or whether our observational horizon has not yet shown us how these walls blend into even larger patterns we cannot see. Inside the walls, Thousands of galaxies share space like cities built along a coastline. Some are young and filled with blue stars. Others are ancient, massive ellipticals that have consumed smaller galaxies in violent mergers. The gas between galaxies inside the walls is heated to incredible temperatures by constant motion and gravity. Radiation flows through these regions at energies far beyond anything our Sun produces. Despite their immense population of stars, these walls are still mostly empty space. But compared to the voids near them, they are vibrant places full of process and change. If an observer lived inside one of the central clusters of a giant wall, their view of the universe would differ greatly from ours. The sky would contain more galaxies glowing brightly across the darkness. Interactions between galaxies would be common events, perhaps even visible over the course of many generations. The environment would be rich with energy, but also dangerous. Collisions could rip worlds apart, and powerful tidal forces could stretch stars into streams. Life might struggle in regions where cosmic violence is frequent. Our quieter location far from one of these walls may be a crucial factor in why life has had the time and calm needed to emerge. Some walls mix with superclusters, merging together into even larger frameworks. The boundaries between structures are not always clear. Just as continents connect through shallow seas, the walls connect through diffuse filaments. The cosmic web is continuous, even if we give names to the brightest parts. This is why discoveries like the Hercules Corona Borealis Great Wall feel so astonishing. They are not isolated objects, but visible portions of a structure that stretches farther than our instruments can map. Much of the universe remains hidden behind distance and darkness. What we have found so far likely represents only the beginning. These discoveries also challenge our assumptions. For many decades, astronomers believed that on the very largest scales, the universe should look smooth and uniform. That belief is based on a principle called the cosmological principle, which suggests the universe should appear roughly the same in all directions when viewed from far enough away. The existence of giants that span billions of light years suggests the universe remains clumpy at scales, previously expected to be smooth. If these structures are real and truly as large as they appear, they ask a simple question. How can such vast formations exist if matter began distributed almost evenly? What physical processes allowed such extreme complexity to grow? The answers are still being explored. It may be that the walls mark the boundaries of huge regions where galaxies formed earlier or more efficiently. It may be that dark matter gathered in thicker filaments in some places than others. It may be that our view is incomplete, and over time we will discover even larger connections that link these walls into something beyond imagination. The universe has a history of surprising us whenever we expand our perspective. As our maps extend and our telescopes deepen, we will continue to uncover features that reshape what we think is possible. Despite their astonishing sizes, these walls are still only structures inside the observable universe. They are limited by how far light has been able to travel since the cosmos began. Beyond our visible horizon, there may be more walls and more filaments continuing the pattern endlessly. We cannot say how large the entire universe is, because light from beyond a certain distance has not yet reached us. We see only a bubble defined by the time since the beginning. Everything outside that bubble remains invisible, not because it is not there, but because light has not had enough time to traverse the distance. This horizon defines what we can observe. It also marks the limit of the giants we can currently map. It is entirely possible that the universe contains structures even grander than the Hercules Corona Borealis Great Wall. Our understanding may be like looking through a narrow window at a landscape and believing the horizon is the end of the world. The true size may be beyond any concept humans have invented. When we think that the universe contains only 2 trillion galaxies, we forget that this number applies only to the observable portion. Beyond that, countless more may exist. Our place in this enormous architecture remains humble. The Milky Way is a single galaxy among the billions that form one small corner of one of many known walls. Everything that has ever happened to humanity has taken place in a region so small that it vanishes entirely when compared with the cosmic giants. Yet, from this tiny vantage point, we have mapped the universe itself. The power of curiosity allows us to comprehend the home we can barely see. These walls challenge human thinking, not only in scale, but in meaning. They remind us that the universe is capable of building structures so large that language struggles to express them. They show that the cosmos is far from simple. It is layered, organized, and drawn by invisible forces into patterns that stretch across time and distance beyond any everyday experience. They urge us to continue exploring, because every time we reach a new frontier, we find that the story does not end. We have journeyed from our local cosmic neighborhood into the greatest structures in the visible universe. Now we stand ready to confront the full scale of existence. To understand how small our home really is, we must compare everything we have seen so far to the entire observable universe itself. Only then will the full context emerge. Only then will we understand just how tiny our island becomes when placed against the backdrop of all that has ever existed. When we look to the deep sky with our most powerful telescopes, we are not simply observing distant places. We are observing the past. Light takes time to travel, and the distances involved are so immense that even the nearest galaxies show us how they looked millions of years ago. The farther we gaze, the farther back in time we see. At the greatest distances, our instruments detect faint glimmers from when the universe was young and new stars were only beginning to ignite. This ability to look backward through time defines the limits of what we call the observable universe. It is not a physical sphere with walls. It is a horizon created by the age of the cosmos and the finite speed of light. The observable universe stretches in every direction for about 46.5 billion light-years. The number is not the age of the cosmos, but the distance light has been stretched while traveling through expanding space. If we attempted to cross from one side of that sphere to the other at the speed of light, the journey would take about 93 billion years. That span contains everything we can currently see from our position inside the Milky Way. It includes more than 2 trillion galaxies, and likely many trillions more too faint or too distant for our telescopes to detect. Every point of light captured by our instruments comes from that region. Beyond it lies darkness, not because nothing exists, but because light has not had time to reach us. This means the universe itself is far larger than what we can observe. The horizon is not a boundary of material reality, but a limit to our understanding. As time continues, new regions will come into view, while distant galaxies may recede so fast that their light stretches away until it becomes undetectable. The observable universe is always changing. It grows with time, but it also loses sight of objects that move beyond a threshold, where light can no longer reach us. The cosmos then becomes a place where visibility itself is temporary. We can see only a fraction of what is truly there. Within this sphere, the cosmic web forms the vast interconnected structure of matter. Every filament, wall, and void we have explored exists inside this observable reach. The walls, such as the Hercules Corona Borealis Great Wall, represent some of the longest structures we can confirm. But even they may be dwarfed by formations lying outside our cosmic horizon. The universe may contain patterns and giants beyond imagination that we will never observe. We must accept that our deepest discoveries so far may be only the smallest hints of a grander architecture hidden in the infinite beyond. When we speak of the observable universe, we are describing a volume that makes our own galaxy seem unimaginably tiny. The Milky Way holds perhaps 400 billion stars, each potentially accompanied by planets and moons. That sounds immense until we place it next to even a modest cluster, such as the Virgo cluster, which contains more than 1,000 galaxies. And the Virgo supercluster is just one part of Laniakea, which holds over 100,000 galaxies. Yet Laniakea is still only a tiny region inside the observable universe. If we compared our entire supercluster to the accessible cosmos, it would amount to only a single drop of water in a world filled with oceans. Even that description is too generous. A drop holds billions of molecules. The Milky Way does not hold a billionth of the galaxies that fit inside our observable view. We are far smaller than small. To visualize the scale, consider this. Imagine shrinking the entire observable universe down until it fits into a single building that spans 100 meters. In that model, the Milky Way would be smaller than a single grain of dust. Everything humanity has ever done would be represented by a tiny imperfection on that grain. Every war and every discovery, every sunrise and every dream, every life that has ever existed, all would be contained in the smallest detail of an object too tiny for most people to notice. This reduction shows just how easily the scale of reality dwarfs the scale of our experience. Yet the scale alone does not capture the wonder. The observable universe holds the entire record of creation that we can currently access. It shows us galaxies as they looked billions of years ago when they were still forming their first stars. It shows us cosmic fossils, the ancient afterglow from the earliest moments of the cosmos. That faint light, called the cosmic microwave background, comes from a time when the universe had existed for only 380,000 years. When that radiation began its journey, no galaxies existed. No stars had yet ignited. Space itself was a glowing ocean of hydrogen and light. As the universe expanded and cooled, that light stretched into long wavelengths that now bathe every corner of the sky. It is the oldest light we can see, a message from the beginning. This ancient glow provides the most profound confirmation that the universe has a history far longer and far stranger than anything humanity once believed. It also sets the outer edge of our view. We cannot see beyond that barrier because the universe was not transparent before that time. The age of light tells us how far our eyes can reach. It tells us that before stars there was darkness, and before galaxies there was chaos. The cosmos unfolded step by step until complexity was possible. We live in a chapter far removed from those early pages, but the story remains encoded in the sky. Inside the observable universe, the number of possible worlds exceeds comprehension. Even if only 1 in 1,000 stars has planets, and only 1 in 1,000 planets is suitable for life, the number of potentially habitable worlds might still be counted in the billions. If we assume that only 1 in a million galaxies has intelligent life, the observable universe would still hold thousands of civilizations. The silence we experience may be a product of distance. Light and radio signals require time to travel. Civilizations may rise and fall during the time it takes for a single message to cross the gulf between galaxies. We may share the universe with countless beings who simply remain too far away to detect. The visible universe is full of extraordinary objects. Some galaxies shine with the energy of trillions of suns. Some harbor black holes billions of times more massive than the one at the center of our Milky Way. Some galaxies rocket away at incredible speeds because space itself stretches between us and them. The universe expands everywhere all at once, and distant galaxies recede faster than light. This does not violate the rules of physics because they are not moving through space so quickly. Instead, space grows between us so rapidly that light cannot bridge the growing distance. These galaxies slip away beyond contact. They will remain in the record of the past, but never again in the reach of our future. This leads to a profound fact. The observable universe is shrinking in a meaningful sense, not physically, but causally. The rapid expansion of space, driven by something called dark energy, ensures that most galaxies will one day disappear from view. Billions of years into the future, observers living in our galaxy may see only a few nearby galaxies. They will think they are alone in a silent and empty universe. Without the faint light from distant systems to guide them, they may never learn the truth we know tonight. They may believe the cosmos is small. They may never discover the cosmic web or the grand architecture of Laniakea. Their horizon will have collapsed to a narrow bubble. Knowledge dies when contact dies. We are living in a fortunate era. We exist at a time when we can still detect the full beauty of the universe. We see the filaments that stretch into the distance. We see the clusters and the walls. We record the light from newborn stars and the faint glow from the beginning. The universe tells us its history in every direction we look. It reveals the scale of existence and the humility of our position within it. We may be tiny, but we are able to understand. That alone may be one of the rarest miracles in the cosmos. Yet even the observable universe is not the final layer. It is only the part we can currently access. Beyond those boundaries, space may stretch endlessly, or it may curve and wrap around itself like the surface of a sphere. There may be more cosmos beyond reach than within reach, perhaps infinitely more. The edge of the observable universe is not the edge of all existence. It is the limit of our knowledge and nothing more. To look beyond that horizon is to step into speculation guided by physics and imagination. It means confronting the possibility that the universe may be far larger than any number we can speak. It means accepting that our visible sphere may be a tiny bubble inside an immeasurable sea. And it means understanding that human existence occupies a vanishingly small slice of a reality that continues far beyond every boundary we have ever known. We have reached the edge of what we can see. Now we must consider what exists beyond sight. The next chapter will carry us past the horizon into a universe that defies measurement. A universe that may not have an end at all. We have traveled outward through every layer of structure that the universe allows us to observe. We have crossed from a single planet to a star system, to a galaxy, to a group of galaxies, to a supercluster, to a vast gravitational basin, and finally to the cosmic web itself. We have reached the limits of our visible universe, a sphere roughly 46.5 billion light-years in every direction. But those limits are not the limits of existence. They are only the limits of light. Beyond that horizon lies a darkness filled not with nothingness, but with places we simply cannot see yet, or perhaps ever. The boundary of our sight is not a wall. It is a reminder that time itself restricts what we may observe. To understand what lies beyond the horizon, we must remember that space is expanding. Galaxies farther away recede faster than those nearby because more space lies between us and them. The expansion is not slowing down. It is accelerating, driven by a mysterious force known as dark energy. Dark energy stretches the fabric of the cosmos, causing distant regions to rush away from one another faster and faster. Because light has a finite speed, there are galaxies so distant that even if light left them at the moment the universe began, it would not yet have reached us today. Those distant galaxies exist outside our cosmic vision. They are real, but permanently hidden behind our horizon. This leads to a remarkable idea. The observable universe is only a tiny portion of the entire cosmos. How tiny? It may be less than a grain of sand compared to the full size of a planet, or even a planet compared to the full size of a galaxy, or perhaps far smaller than that. Some cosmological models suggest that the true universe could be hundreds or thousands, or even uncountable orders of magnitude larger than the part we can see. Space may continue on and on without ever looping back. Or it may curve gently into a closed shape so vast that even crossing its full length at the speed of light would take longer than the current age of all existence. We do not know which is correct. We may never know for certain. One possibility is that the universe is infinite. If space stretches without end in every direction, then the observable universe is only one patch on an endless sheet. In such a universe, there would be no center, no boundary, and no special place. Our location would be just one coordinate among infinitely many. In an infinite cosmos, every arrangement of matter that is physically allowed might repeat somewhere else. There could be regions of space identical to our own, separated by distances so enormous that no signal could ever travel between them. The idea of duplicates of ourselves is not fantasy. It is one of the logical consequences of infinity. If possibilities are unlimited, and space is unlimited, then repetition becomes unavoidable. Another possibility is that the universe is finite but unbounded, like the surface of a sphere. On a sphere, you can travel endlessly without ever encountering an edge, yet the total area is still limited. If space behaves similarly, then the universe might wrap around itself. If you traveled far enough in one direction, you might eventually return to where you began. To us, this would be indistinguishable from infinity, unless we could detect the subtle patterns that such a shape would create in the distribution of galaxies, or in the ancient light left over from the beginning. Scientists search for those patterns, but so far the results remain unclear. Whether the universe is finite or infinite, the horizon will always hide parts of it from us. Dark energy ensures that more galaxies will cross beyond visibility as time goes on. Our cosmic island will shrink not in physical size, but in what it can interact with. One day, far in the future, observers in our galaxy may see only the remnants of our local group floating in silent darkness. They will know nothing of the cosmic web surrounding them now. Their universe will seem tiny, lonely, and devoid of grand structure. They will believe that the Milky Way, or whatever it becomes, is the entire cosmos. History will be forgotten not because of ignorance, but because the universe itself will erase the evidence. We are lucky. We exist in a moment when we can still see the universe in nearly full splendor. We can map filaments that stretch for hundreds of millions of light years. We can observe walls that extend across billions. We can detect the faint glow from the earliest time when atoms first formed. We can measure the expansion of space and infer the presence of dark matter and dark energy. We are alive in a chapter of cosmic history when the truth is still visible. The night sky still holds the story of everything that came before. Beyond the horizon may lie regions where physics behaves differently. The values of fundamental forces may vary. The particles that shape matter may not exist in the same combinations. Stars might burn in unfamiliar colors. Galaxies might never form. The cosmos may stretch endlessly into realms that bear little resemblance to our own. In some theories, the visible universe is only one bubble inside a foam of countless expanding bubbles, each with its own version of reality. This concept, called the multiverse, is difficult to test, but it arises naturally from the mathematics of cosmic inflation, the theory that explains how the universe expanded rapidly in its earliest moments. Inflation suggests that space did not simply grow. It erupted outward at speeds far beyond what light can accomplish. In that eruption, separate regions of space may have become isolated forever, forming multiple universes. Our observable realm would then be only a tiny section of one bubble, floating in an infinite sea of cosmic expansion. Each bubble might contain different histories, different outcomes, and different possibilities. It may even be that life flourishes in some, while others remain barren. In this view, the cosmos is not merely large. It is beyond comprehension. Even if the universe contains multitudes of unseen worlds, we may never reach them. The horizon forms a permanent boundary to travel because expansion outpaces motion. Where space grows faster than any ship can move, exploration ends. The greatest mysteries remain beyond a wall that no technology can breach. Our knowledge is limited by cosmic fate. And yet the human spirit does not accept those limits easily. We continue to search. We build instruments that expand our vision. We learn to read the faintest signals in the sky. We imagine what may lie beyond. Beyond the observable universe lies a realm that will always remain theoretical. But that does not diminish our curiosity. Imagination becomes our tool when direct observation fails. Through reason and physics, we can trace the possible shapes of what we cannot see. We can explore the landscape of existence with our minds even when our telescopes cannot follow. What lies beyond the horizon is ultimately a question about ourselves. It challenges our need to understand and our desire for meaning. The universe beyond view may be infinite or finite. It may hold endless galaxies or none at all. We may never travel there. But the fact that we can ask the question, means that even from our tiny corner of one galaxy, we have begun to comprehend the true scale of reality. As we continue our journey outward, we must remember that despite all this immensity, our existence is fragile. The next chapter will bring us back from the edge of the unknown to reflect on the delicate conditions that allow life to survive in such a vast and indifferent cosmos. We will see how our position in the universe influences our future and how easily everything we know could vanish. We have traveled outward into a universe so immense that every layer of scale has made our home feel smaller and smaller. We have left behind planets, stars, galaxies, superclusters, and even the full observable sphere that defines the reach of our vision. Now it is time to turn around and look back with new understanding. Because while the cosmos is large beyond measure, the existence of life appears to be something delicate, requiring a combination of circumstances that is incredibly rare. Our place in the universe is not only tiny, it is fragile. Life as we know it depends on specific conditions. We require a stable star that shines steadily for billions of years without violent eruptions powerful enough to sterilize nearby worlds. Our sun meets that requirement. It is neither too hot nor too cold. It does not burn its fuel too quickly. It provides gentle heat and reliable light. Many stars are not so generous. Some flare violently, bathing surrounding planets in radiation. Others shine only briefly before dying in explosions that scatter elements into the void. Earth is lucky to orbit a sun that offers calm stability. Our planet also exists at the right distance from the sun. Too close and air and oceans would boil. Too far and everything would freeze. Earth orbits in a narrow band sometimes called the habitable zone, where liquid water can exist on the surface. Water is essential to life because it dissolves molecules and transports nutrients throughout cells. A world without liquid water is a world with no seas, no rain, and likely no living creatures. Planets in the habitable zone are not guaranteed to hold water, but they have the possibility, and possibility is all that nature needs. The sun itself orbits the center of the Milky Way. Our location is another quiet advantage. Near the galactic core, radiation bursts from supernova explosions, and powerful jets from the central black hole frequently tear through space. Crowded regions contain too many hazards for life to calmly develop. We reside far out in one of the spiral arms, in a place with fewer collisions and fewer catastrophic events. The Milky Way has places far more beautiful to photograph, but few more suited for the slow, careful work of evolution. The presence of a dark matter halo around our galaxy also contributes to our safety. Though invisible, its gravitational influence regulates the motion of stars and gas. Without dark matter, the galaxy would spin apart too quickly and chaotic change would dominate. The halo shapes a stable environment where stars can live long enough for life to rise and evolve upon their planets. Our survival depends on forces we cannot see. The invisible protects the vulnerable. Even the moon plays a role in our safety. Its gravitational pull stabilizes the tilt of Earth. Without it, our planet might wobble unpredictably over time, causing chaotic climate changes that would challenge or prevent the development of complex life. The moon also drives tides that shape coastal environments where early organisms may have first adapted to life beyond the sea. That quiet companion above has guided life more firmly than we often realize. Asteroids and comets pose threats, yet they also deliver essential ingredients. Impacts early in Earth's history may have brought water and organic materials to the surface. Too many collisions would have destroyed life before it could begin. Too few would have left Earth barren. Our solar system provides just enough gravitational shepherding to ensure that catastrophic impacts are rare. Jupiter, especially with its enormous mass, acts as a guardian, capturing or deflecting dangerous objects. It is a giant shield orbiting far beyond our world. Despite these protections, life has nearly ended several times. Mass extinctions have swept across Earth, erasing most species and forcing evolution to begin again. Volcanoes, shifting continents, and falling space rocks have shaped the path of life. Catastrophe and resilience wrote the story of our existence. We are here because life endured through every challenge the universe presented. Fragility and tenacity intertwine. When we consider everything required for life to emerge and thrive, we begin to see that our cosmic address is uniquely favorable. If Earth orbited a different type of star, if it sat deeper in the galactic core, if dark matter were distributed differently, if giant planets did not exist to guard our skies, if the moon were too small or too distant, or did not exist at all, then the long chain leading to conscious beings might never have formed. We are here because of countless coincidences balanced so precisely that they appear more like necessities. Our existence is the delicate product of a dangerous universe. Radiation storms swirl between galaxies. Black holes consume anything that drifts too near. Supernova explosions release more energy in seconds than stars like our Sun emit in their entire lifetimes. Collisions between galaxy clusters tear apart entire worlds with forces beyond imagination. Even space itself stretches with accelerating speed, threatening to push distant galaxies completely out of reach. The universe does not provide gentle environments easily. Life must find rare pockets where peace can last long enough for complexity to grow, and yet here we are. A thinking species living in the thin atmosphere of a small planet, floating inside a quiet cosmic neighborhood. We question the universe that created us, even though we represent an almost invisible presence within it. The cosmos is ancient, heavy, and vast. We are young, light, and small, but we are aware. Awareness is the spark that makes a fragile life form part of something far greater. When we look outward, we feel tiny. When we look inward, we find meaning. The universe does not shrink because we understand it. It expands with every discovery. Knowledge enlarges existence rather than diminishing our importance. Our fragility is not a weakness. It is a sign of how our extraordinary survival is in a world that does not promise it. Our place in the cosmos is both insignificant in scale and immeasurable in value. We are a moment of light inside a boundless darkness. And though that silence may endure long after we are gone, the fact that we existed at all adds a new chapter to the history of the universe. The cosmos may not notice us, but we notice the cosmos. From this perspective, everything changes. Home is not just a planet or a star, or even a galaxy. Home is the small, safe corner of an immense universe where life was able to take hold. Home is a structure that protects a fragile spark. Home is existence. We have explored the scale and structure of the universe. Now one final step remains. We must return to where we began and place our story into a single sentence. Everything we have seen leads to one truth. Our home is smaller than we ever imagined, but it is everything to us. We have journeyed outward farther than any spacecraft could ever fly. We have traveled with imagination as our vehicle and knowledge as our map. We stepped away from Earth into the realm of planets, from planets to stars, from stars to a galaxy of hundreds of billions of suns, from that galaxy to a community of galaxies, from that community into a supercluster of unimaginable scale, and then beyond that, into the basin of gravity called Laniakea. And farther still, we trace the filaments of the cosmic web and the colossal walls that define the boundaries of cosmic structure. We have reached to the edge of the visible universe, where light that began traveling when the cosmos was still young only now arrives at our eyes. Then even beyond that edge, we considered what may lie hidden. Through every step, our home has grown smaller and smaller, until it seems nearly impossible that such smallness could contain beings capable of asking big questions. Earth is a delicate sphere of blue and white, lost in a vast wilderness. It orbits the Sun, a single star, among perhaps 400 billion inside the Milky Way. The Sun itself is nothing extraordinary. It shines with average brightness. It occupies a location that is neither too near nor too far from the center of the galaxy. It has no special claim to being important, yet around it circles the only place we know where consciousness has arisen. Everything that has ever lived exists on that thin surface layer, where land meets sky and water. That narrow region of warmth and air is the entirety of our known life-bearing universe. Remove a small fraction of it, and the entire story of life would vanish. From the perspective of the cosmic web, Earth is nothing more than a pinpoint held together by the most delicate of balances. Gravity holds its atmosphere. The magnetic field shields it from the dangerous storms of the sun. The oceans moderate temperature and cradle the chemistry of survival. Its orbit remains steady enough that life evolves without sudden interruptions that wipe the slate clean too often. We walk on solid ground, but in truth, we are walking on a tightrope stretched across a cosmic abyss. We survive because nature allows us to, just barely. We are surrounded by silence. Even the nearest stars are so far away that a beam of light must travel for years to reach them. The gulf between galaxies swallows light for millions of years. And yet, in all of that distance, in all of those unfathomable volumes of space, we have found only one world bursting with life. That rarity makes Earth more valuable than any jewel, any treasure, and any discovery we may ever uncover in the blackness between the stars. We cling to this small world, not because we fear the universe, but because we understand how extraordinary this place truly is. Our insignificance in scale does not diminish our significance in meaning. The universe does not need to be small for us to matter. We matter because we are capable of wonder. We are able to ask what lies beyond and then seek the answer. We are able to look at the night sky and feel awe instead of fear. We are able to learn that we are not the center of everything and still feel joy in the discovery. A species that can understand its insignificance has already transcended it. Awareness is the rarest substance in the cosmos. Stars burn, rocks endure, but only life can contemplate its place in the grand picture. When we learned that Earth orbits the sun, we were humbled. When we learned that our sun is one star in a galaxy of many, we felt smaller still. And when we understood that even the Milky Way is only a passing spark in a universe crowded with galaxies, we were forced to rewrite every assumption humans once held about the heavens. The deeper truth is that we must continue rewriting. Every new discovery makes the cosmos larger and our home smaller. Every addition to the cosmic map pushes us farther away from any notion of centrality. We do not live at the center of the universe. We do not even live at the center of our own galaxy. We are residents of a humble address, drifting among structures whose sizes reduce us to the edge of invisibility. And yet we remain. We build observatories to measure the universe. We launch instruments into space to gather light from places no living creature will ever reach. We decode the faint whisper of the earliest radiation left behind from the beginning. We transform that whisper into knowledge. We convert knowledge into understanding, and through understanding we find meaning. We are small, but we are not powerless. Take all of human history. Every triumph, every failure, every hope, every civilization, every memory, every dream. Compress it into a single tiny fleck of existence. That fleck would still be too large compared to the actual slice of the universe in which we reside. But that fleck is conscious. It recognizes the enormity of what surrounds it. It sees its home not as the center of creation, but as one part of a much grander design. This ability to see beyond ourselves is the most precious achievement life on Earth has ever accomplished. But what does it truly mean to call this place home? Home is not the universe. Home is not even the galaxy. Home is the fragile cradle that supported our rise. Home is Earth. Home is the sun that warms us. Home is the improbable combination of chance and chemistry that allowed life to appear. Home is the narrow region of safety where our species can breathe, grow, and imagine a future. The cosmos may be vast and eternal, but our home is the one place we can belong. For now, it is enough. We must hold our smallness not as a wound, but as a wonder. Our size does not define our worth. Our awareness does. The universe will continue expanding. Stars will continue forming and dying. New galaxies will take shape, while old ones are torn apart by gravity. The cosmos will not pause to notice us, yet we notice it. We are the eyes through which the universe beholds itself. That is our role. That is our meaning. We have returned from the outermost reaches of our imagination back to this small speck of existence, but now we see it clearly for what it is. This world where we are born and where our stories unfold is a miracle balanced inside a universe that rarely makes room for miracles. Earth is not at the center of anything except our own experience. It is not held in a privileged location or guarded by cosmic design. It is sheltered by luck and shaped by chance, and yet everything we cherish depends upon it continuing to be exactly what it is. This fragile sphere is the only place where the cosmos has opened its eyes and learned to understand itself. Life does not emerge easily. It requires a stable star shining for billions of years with gentle light and patience. It requires a planet placed at the right distance, where water can flow and mountains can rise, and storms can nourish rather than destroy. It requires chemistry that builds structures capable of copying themselves and evolving over time. And it requires a peace that lasts long enough for memory and language and curiosity to appear. Earth has provided those gifts. It has given us an unlikely sanctuary where thought can rise above instinct and seek truth. From this sanctuary, humans have dared to explore not only the land and the seas, but the very nature of reality. We have asked questions about our past and our future. We have studied the motions of stars and learned that we are not the center of the heavens. We have watched galaxies drift away faster than we can chase them, and accepted that the universe will always be larger than our reach. We have discovered that beyond the visible horizon lie realms forever hidden from our sight. Yet none of these truths have diminished us. They have illuminated us. For a species that occupies less time than a blink in the history of the universe, we have learned more than anyone could have predicted. We have mapped the cosmic web. We have measured the age of the universe. We have traced the origins of the atoms inside our bodies to the hearts of ancient stars. We have learned that every element of life was forged in fire by suns that lived and died long before Earth existed. We carry the ashes of those stars inside us. We are literally made of the universe. And that means something. It means that when we look upward, we are not gazing at something foreign. We are looking at our own origins. The universe is our ancestor. We are threads woven into the same cosmic pattern that binds galaxies to filaments, and filaments to walls and walls to the expanding fabric of space. We belong to all of it. We always have. We always will. As we understand the immensity of the cosmos, we also understand the responsibility that comes with our existence. Fragility demands protection. Awareness demands purpose. The universe is not fragile. Stars explode without caring what worlds they destroy. Black holes swallow light without apology. Expansion drives galaxies apart until they vanish from sight. Physics is not sentimental. But life feels. Life remembers. Life understands that a single world alive with thought is more precious than any empire of lifeless suns. So what should we do with this knowledge? We must protect our home. We must preserve the thin line that separates life from silence. We must treat every breath as a gift, borrowed from a universe that does not often lend such gifts. We must explore, continue asking questions, continue seeking answers. Curiosity is our oldest instinct and our greatest strength. It led us out of caves and into space. It will one day lead us to other worlds, perhaps even to new homes among the stars. Curiosity is the fire that keeps awareness burning inside the darkness. We are small, we are brief, but we are awake. We know what the cosmos is. We know where we live within it. And despite its magnitude, the universe does not overwhelm us. It inspires us. It teaches us that small things can reach far, that tiny sparks can ignite great discoveries, that the smallest point of light can still illuminate the largest expanse of night. So let us speak our true cosmic address one final time. We live on a world called Earth. It orbits the Sun, a single star in the Orion arm of the Milky Way. That galaxy belongs to the local group, which drifts inside the outskirts of the Virgo supercluster. That supercluster is one region of Laniakea, the immeasurable heaven. Laniakea is one flow inside the cosmic web, a structure of filaments and voids that spans the entire observable universe. And beyond that observable horizon lies more universe than we can ever see. That is our home, tiny and magnificent, ordinary and miraculous. A brief moment of warmth inside a cold eternity, a flicker of thought in a universe mostly silent. We are not the center of the universe. We are not even near the center of our galaxy. We are a momentary spark on a dust mote floating in a limitless ocean, but we are the spark that knows the ocean is there, and that is enough.